Hello, everyone. Let's go over this worksheet that we had about ways to prove triangles congruent. The first part of this focuses just on the side, and side angle side postulates. So let's read through those really quickly. Side postulate said if three sides of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent to each other. So, not knowing what the angle measures are at all, if you know all three sides of one triangle are congruent to its corresponding parts in another triangle, that's enough. Also, the side angle side congruence theorem says two sides and the included angle of one triangle are congruent to the corresponding parts of another triangle, then the two triangles are congruent. So remember, the angle has to be included. It has to be between the two known congruent sides. If it is not where those two sides meet, then it is not the included angle, and you can't use the side angle side postulate. So let's take a look at these. All right, we have number one. This is the most obvious and basic version of the side postulate I can come up with. So I'll just write that right here. Side. Okay, you have this side is congruent to this side. That's one. This side is congruent to this side. That's the second side. And then the third side is congruent to the third side. All three sides have a corresponding congruent side. You can use side to prove these two triangles are congruent to each other. Let's move on. Oh, that's crazy. Okay, moving on. And number two, well, you only have two sides now. You have this side is congruent to this side because they both have two tick marks. This one is congruent to this one. And then the angle between them is 90 degrees, and all right angles are congruent. Euclid said that. So since all right angles are congruent, those two angles are congruent. And since that angle is where the two known sides meet each other, it is the included angle. So you could use side angle side for this. I could prove those two triangles congruent using side angle side. Now, and number three, okay, so this side is congruent to this side. This side is congruent to this side. And this angle is congruent to this one. So you might be thinking, oh, side angle side. But I want you to notice something. The angle is not in the right place. Had that angle been up here and up here, then we would be all set. We could use side angle side because that's where the two known sides meet each other. But that angle is not the included angle. So this one we can't prove. There's just not enough information. Now, in number four, we have isosceles triangles. Two isosceles triangles, and you have a lot of matched up sides. This one matches up with either this one or this one. That one, the same. And the angle we know is between those. There's actually some properties of isosceles triangles that would include more options for how to prove these two triangles are congruent to each other. But with what we're giving right now and not using the base angles theorem or the converse of the base angles theorem, we can still say that these two are congruent to each other using the side angle side postulate. All right, number five is our first triangle that has a shared side. So look at this side right here. It is shared between the two triangles. This side is going to have the same measurement as itself, and the reason for that is because of the reflexive property. Whenever that happens, I usually put 3 lines through it like that. And just know that that side is the same in both those triangles because it physically is the same side. It has to have the same measurement in both triangles. And as a result, now we have enough information to say side, and then our reflexive side. So these are congruent using side. One of the major things you're always going to look for when you're trying to prove triangles are congruent are reflexive sides that are the same in two different parts of the shape. Number 6. Oh, you know a lot about angles here. you know that this angle is congruent to this one, you know that this angle is congruent to this one, and you know that this angle is congruent to this one. And all of that is very useful if you are trying to prove these triangles similar to each other, but you can't prove triangles congruent. So I'm going to say they're not congruent, only similar. Triangles that have the same angles as each other are always going to be similar. If all three angles are congruent to each other, great. Those triangles are definitely similar. But you can't necessarily prove they're congruent unless you know at least one side is congruent between the two. Let's move on. Oh, here's the other thing that you always look for. We do know that this side is congruent to this side, and this side is congruent to this side. You don't necessarily know anything about the other side, or at least I can't tell anything about it. But we have an angle here. These angles are vertical angles, and the vertical angles theorem said that all vertical angles are congruent. So this angle right here is congruent to this one because of properties of geometry. Now you know enough information to prove that these two triangles are congruent. You can say this side, the included angle in this side, match up with this side, the included angle in this side. And you can use side angle side to prove those two triangles congruent. Number 8 is my favorite one. There's two possible sets of triangles you can prove in this diagram. Also, this diagram in number 8 has 6 triangles in it. Let's see if we can go through all 6 of them. Here's 1. Here's 2. Here's 3. And then here's 4. Here's 5. And then finally the big one, 6. So there's 6 different triangles. And I can prove 2 different pairs of them are congruent to each other. But let's start off with the most obvious one. We can prove that this triangle right here is congruent to this triangle right here using this side, side, side. Side, side, side postulate. So that's enough. And we could just move on. But I want to show you something a little bit more. Let me take a look at this. If you look at this triangle, we know 2 of the side measurements, and then the bottom we know a piece of the measurement, and then there's going to be a part that's going to be shared with what it's congruent to, and that's this one. I can also prove those 2 triangles congruent using side, side, side. I would have to add in some segment addition postulate for this little section on the bottom because that line segment is in both triangles, but we can add it to the red triangle and the blue triangle, and I would be able to prove that those 2 triangles are congruent to each other, as well as those smaller ones I started out with. But both of them would be proven using side, side, side eventually. Oh, look at this one. Oh, we have angles. There's something weird about the angles though. Look, this angle is between the 2 sides that we know, and this angle is not the included angle. It would be this one over here, and then we could use side angle side. But none of that matters because we have a reflexive side, and we don't need to use side angle side when we can use side, side, side to prove these 2 triangles congruent. And what this really tells me is these are isosceles right triangles. So that opens up a whole other thing. Okay, we have 2 equilateral triangles that all 3 sides in each triangle are congruent to each other. This one is definitely a side, side, side. Congruence postulate triangle set. Not only that, it's like the easiest one because even if we had A, B, C, and then D, E, F for vertices, any combination of those 3 would actually make a proper congruence statement because each side and each angle are going to be congruent to each other. So that one's actually pretty fun. Okay, in this one we have a couple angles that are congruent, and then we have a reflexive side. Make sure you mark that. So I see that we have a side, an included angle, and another side that match up with a side, an included angle, and another side. So that one is going to be a side angle side, congruence triangle, which is great. It's great. All right, moving down. And the final one on this page is two very cool looking obtuse side triangles. I can prove them congruent using side. I don't know anything about the angles. They look obtuse, but that's not going to help me prove they're congruent. But knowing that all three sides have a corresponding side in the other one, that's how I'm going to get there. All right, see you on the next page. So here we are. Now we're going to focus in more on the angle side angle side, and hypotenuse leg congruence theorems. So angle side angle means two angles and the included side of one triangle are congruent to the corresponding parts of another triangle. The triangles are congruent. And then angle side says that two angles in the non-included side. So the side isn't between the two angles. And what this really tells me is if you know two angles are congruent between two triangles in at least one side, whether it's between the two angles or not between the two angles, you can prove those two triangles are congruent. You just have to pick the right one. The hypotenuse leg is the weird one. It only has two words, so not three. But also, it only works for right triangles. So the hypotenuse, meaning the longest side of the right triangle, or the side opposite the right angle, and a leg of one right triangle are congruent to the corresponding parts of another triangle. So when you have a right triangle, the hypotenuse is the longest side, and then the other two sides are just called legs. So if you know that, it's kind of like two sides of one triangle are congruent to two sides of the other triangle, but you also know that they're right triangles. And so this would be like the side angle postulate, but it only works for right triangles. It doesn't work for acute or obtuse triangles. And when you take pre-calculus, you'll learn exactly why. Okay, so let's take a look at these problems and see if we can solve some of them. So, number one, two triangles. You have this angle matches up with this angle matches up with this one, and then the side that connects those two angles matches up with the side that connects those two angles. Since that side is between both of the angles, I will use the angle side angle postulate. And notice when you write ASA, the side is between the two angles, just like it is in the diagram. So that's why I picked that one. Okay, we have some right triangles here. So whenever you see right triangles, it might be hypotenuse leg. And we do know that the hypotenuses are congruent. So right triangle, we have the hypotenuse is congruent. But what about a leg? That's the only markings we have. Oh, but we have a reflexive side that we can just see. So I know those sides are the same as each other in each of the triangles because they are physically the same side. So I can prove these two congruent using hypotenuse leg. The legs are the reflexive side, and then the hypotenuses are the other longest side that's opposite the right angle. Remember, right angle and its opposite side is the hypotenuse. Cool. Let's move on to this one. Oh, we have two sides and an angle. Well, that's nice, but the angle that we know is not in the right spot. Knowing two sides and an angle doesn't guarantee that the triangles are congruent. If it's a right triangle and one of the sides that you know is the hypotenuse, that helps, but I don't think that's the case here. It doesn't even look like a right triangle, and we certainly don't have a right angle marker. So we can't use hypotenuse leg. You only know two sides, you can't use side. You only know one angle, so you can't use angle side angle or angle side. We can't even figure out the other angle because they're not part of, there's no vertical angles to figure out another angle. So the only one left is side angle side, and we have two sides, but the angle that we know is not between the two sides. If it was this angle here or this angle here, then we'd be able to say side angle side. But since it's the non-included angle, can't use anything. And now I don't know if these are congruent or not, but I know I don't have enough information to prove that they're congruent. So you can't assume that they're congruent just because they look alike. Oh, here we have two sets of angles. This angle is congruent to this one. This angle is congruent to this one. That's great. And then or at least you can see that there's a side shared between the two triangles. So this is a reflexive side. It's in both of them. It equals itself. So we have two angles and a side. Whenever you have two angles and a side, you know you can prove them congruent. You just have to pick angle side angle or angle side. The side we know is not directly in between. It does not come in contact with both of those angles. It just comes in contact with one of the angles. So when that happens, you have angle side. There is something called the third angles theorem, which you could use to prove that this angle is the same as this angle. And if you're doing a formal proof, you might do that and then use angle side angle, and that's totally fine. But it's a little faster if you just go right to angle side. You don't have to have an extra step in that proof, a third angles theorem step. All right, moving down. This is a very clear angle side angle. You have two angles on the side in between them that are congruent. Great example of an angle side angle problem. Ooh. Oh, we have a bow tie problem here. At least that's what I call them. Whenever I see vertical angles, I always think it's a bow tie, even though this one's kind of rotated a little bit. We have vertical angles. I know those two angles are congruent to each other. I could see it from far away, so I just wrote it in. These are also right triangles, and so you have these right angles that are also congruent to each other. Right triangles also makes you think a little bit about a hypotenuse leg, but notice I only know one side, the hypotenuse. I don't know what either of the legs are. So that's not going to help me with hypotenuse leg, but I do know two angles on a side. The side is not in between the two angles. Both angles don't come in contact with that side, just the vertical angle does. So this is an angle side. Okay, we have two triangles here. They're right triangles. We know two of the legs are the same. But the only angle we know anything about is the right angle. The top up here, that's not a vertical angle. Those aren't the same lines continuing through each other, making an intersection. So you don't actually know anything about those angles. You do know these are right triangles. You don't know anything about the hypotenuses. Hypotenuse legs out, side's out, side angle side is out because you only know one side. Angle side and angle are out because you only know one angle. These do not give us enough. We do not have enough information to prove these are congruent. So in math, they're not congruent until you can prove they're congruent, even if they look congruent. Oh, okay. This one's a little elaborate. If you were going to write a 2-column proof on this one, it would take you a couple extra steps because there's a segment down right here. Let me get a good color that you'll be able to see. There's a segment right there that's included in both, that's reflexive in both, but it's not an entire side length. But if you add that to this triangle and you add it to this triangle, that would compose an entire side of this. Add to that the fact that these are right triangles, and you know that both of their hypotenuses are congruent to each other. There is a way that you could actually prove these two triangles congruent using the hypotenuse leg congruence postulate. You'd have to do some work in this middle part here using the segment addition postulate, but it could be done. Moving on. Ooh. Once again, you have isosceles triangles. They might not look isosceles to you at this point, depending on whether or not you've learned about isosceles triangles, but they definitely have two angles that are the same. And the converse of the base angles theorem says that the sides opposite those angles also have to be the same. But even without that, I can use the angle side angle postulate to prove that these two are congruent. And there's a bunch of different ways I could write this statement because you have two congruent angles between each of the triangles. So they match up a lot of different ways. But we'll just keep it simple for now, and we'll just say angle side angle would be the best way to do that. And this final one, this one should be awesome. One angle, two angles, and then a non-included side. This one is going to be angle, angle, side. For this third page, we're going to use any of the 5 congruence postulates and theorems. Side, angle, side, angle, side, hypotenuse, leg, or none. Some of these won't work, including the first one. The first one only gives us 2 angles. We could use the angle postulate, but that only proves similarity. So these two I know are similar, but not congruent. Number 2. Oh, here we go again. We have 2 angles in one triangle, 2 angles in the other triangle, but this one has a little bit more information. We have a reflexive side between the two. So since we have 2 angles in the non-included side, I would use angle, angle, side with number 2. Number 3. Now, without knowing anything about isosceles triangles, you can't prove these are congruent. You have 2 sides in a non-included angle, so you can't use side, angle, side. You can't use side, side, side. You can't use hypotenuse, leg. They're not right triangles. And angle, angle, side, and angle, side, angle, to this point, you couldn't use. So without using the base angles theorem, you can't prove these are congruent. But the base angles theorem says that the sides opposite isosceles triangles are also congruent. So, or the angles opposite the isosceles sides are also congruent. So I know that those two are actually congruent to each other. And now I could use angle, angle, side. But without using the base angles theorem, that would be impossible. Let's move on. Okay. Oh, we have 2 sides and an angle. Oh, and look right here, the angle is between the 2 sides. But be careful, this angle is not between the 2 sides. So this one is going to be none. If the angle in the right triangle was given right here, this would be side, angle, side. But since it's this one over here, then the non-included angle, we can't prove they're congruent. Okay, but here we have a pretty clear, this angle matches with this one, this angle matches with this one, and the included side matches with this included side. I will call this angle, side, angle. Moving over to number 6. Okay, we do know some angles. We know this angle and this one at the top. Let me do that again. This one and this one. Oh, we also know there's a right angle. Maybe we're thinking a little hypotenuse leg, maybe not. We have a reflexive side as well. So now we have a side, but we only have one side, so we can't use hypotenuse leg. Even though they're right triangles and we know the hypotenuses are the same, we don't have any legs. We only have one side that's known. But don't despair. Right angles are always congruent to each other. And then we have a second angle that is congruent, and then a non-included side. This is an angle, angle, side. Oh, there's so many ways to prove this one. First off, there's 3 sides of one that are congruent to 3 different sides of another. This would be a side, side, side. But beyond that, it's also features vertical angles right here. So you could also use side, angle, side to prove these 2 triangles congruent. So that's pretty cool. There's actually 2 correct answers for that one. One using vertical angles and one just using the side lengths that were given to you. But either way, that's a good one. I like that one. And it also looks like a bow tie, which is a bonus. Oh, here we have 2 right triangles. We know that our hypotenuses are congruent. We know that one of the legs there are congruent. This is the absolute definition of a hypotenuse leg pair of triangles. The orientation's the same. Everything works out with those. And number 9, we have a shared side. We have a side that's reflexive to itself. And then we have an angle, and then we have another side. This one's going to be a side, angle, side. The angle that we know in this one is between here. This angle is between this known side and this known side. So that works for side, angle, side. And in this one, we know this side, and the angle between them. The angle that we know is in contact with both of the sides. It's the angle that's formed by their intersection. So that's the side, angle, side. 10, nothing but angles. We can totally prove these similar to each other, but there's no congruence postulate that we can use. So I'll just say none. And number 11, they give us a bow tie problem, and they even marked the vertical angles for us. So we have 2 sides in the included angle. This is side, angle, side. Okay, we have a bow tie problem here with a vertical angle, and they didn't mark it for us. I'll put 2 lines through it because one arc is already used. So we have 2 angles and a side. So this angle matches this one. This angle matches this one, and the included side matches up with the included side. This one is an angle side angle. That would be the fastest way to prove it. Number 13. Okay, we have right angles. We have this side is congruent to this one. This side is congruent to this one. The angle we know is not in between the 2 sides, but these are right triangles, and we do know the hypotenuse are congruent, and we know one of the legs are, so this would be a hypotenuse leg. Number 14 is a very clear side, side, side. I don't think we have to go over that one too much. The orientation is perfect. And then number 15, you have 2 isosceles triangles. You have the base angles are congruent, but there's a problem with this one. This one has 1 tick mark, so it matches up with this one, but in the other triangle, it doesn't correspond. These sides don't correspond with these sides, and these angles don't correspond with these angles. Since nothing actually corresponds between the 2 triangles, even if they correspond within their own triangles, there's nothing you can use to prove these 2 triangles are congruent to each other. All right, that's it. Good luck.